Section 4.4, Laws of Logarithms, Part 2. We have three laws that we can use with logarithms. We can use the laws from left to right, but we could also use the laws from right to left. If we use the laws from left to right, what we can do is multiplication gets separated out with addition. Notice that we keep log A. If we have division, we can separate out with subtraction. If we have an exponent, that exponent can be written out front of the logarithm. Okay, so working left to right, multiplication, separate out with addition. Division, we separate out with subtraction. Powers, we bring the powers out front. Okay, so not only working from left to right, we can also use these rules from right to left. If we use the rules from right to left, as long as these are the same base and I'm adding, I can take A and B and bring them together with multiplication. As long as we have the same base and we're subtracting, I can bring these two together with division. If I have a number out front of the logarithm, I can clear that number out front of the logarithm by making it an exponent. Okay, so let's look at how we can work with these laws and problems of section 4. I think this is 4.4. Okay, so what operation do we have? Here we have the operation of multiplying. If I'm multiplying, I can separate everything using addition, and that was law number 1. So we have log base 5 of 4 plus log base 5 of s plus log base 5 of t. With multiplication, we can separate our log with addition. Okay, problem number 28. Let's first rewrite. This is log base 10. 10 is used so often, we don't write it. Just like when we don't say x to the first, we just say x. We don't say log base 10 because it's used so often, we just say log. Remember from a section previous, that's the common logarithm. Okay, so let's see if we could write t to some power. It's already underneath the radical to the 5th power. The square root has an index of 2, so we can write this as t to the 5/2. Okay, now which of the laws apply? Law 3. We have an exponent, and what our law says is we can bring that exponent out front. So this would become 5/2 log t. Okay? All right. Use the law of logarithms to expand. Okay, so if we're expanding, we're making the expression larger. So we're using our rules from left to right. When we see a multiply, separate with addition. We see a division, separate with subtraction. We see a power out front, bring the power, if we have a power, we bring the power out front. See log base A of A. Okay, so let's look at problem number 34. We're going to start out with just the division. If I have a division, we separate out using subtraction. Now I put parentheses here because it's the 3 and the s that belong in the denominator. So the 3 and the s belong to this minus. Then I go to law 1. What does law 1 say? Law 1 says if this is multiply, I can separate these with addition. And then if I distribute that negative, this would be considered completely expanded. Now I like to do a quick visual. Does my answer make sense? When I do my quick visual, if there's a plus here or it's positive, that meant r was from the numerator, and it was. If I see a minus, that means these came from the denominator. The minus ln 3 must have been in the denominator. Minus ln s, the s must have been in the denominator. And that's what we had started out with, so I'm pretty sure that we have a good answer. Okay, so let's look at starting out with the division. Okay, so we're going to have log base 2 of s to the 5th. Division we separate out with subtraction. Log base 2 of 7t squared. Okay, exponents. Exponents we can bring out front. So we bring that one out front. So that gives us 5 log base 2 of s. Okay, let's work on this multiplication. What we learned is if we have multiplication, we can separate that out with addition. So that would be log base 2 of 7 plus log base 2 of t squared. Now I'm going to go ahead and distribute that negative. So we have 5 log base 2 of s minus log base 2 of 7. We're just distributing this negative to both terms. So that becomes a minus log base 2 of t. And then this squared, I'm going to just go ahead and bring that out front. So that would become a 2 here. And we've completely expanded. Now doing my quick visual, if this is a plus, that meant s to the 5th was in the numerator. And so far so good. If we see a minus, that meant 7 came from the denominator, and it did. If we see a minus, that means t squared came from the denominator, and it did. So I'm pretty confident I have a good answer. Okay, now we are going to combine. If we combine, we're going to make the expression smaller instead of it being so large. When we combine, we're going to move in this direction. We check, are they the same base? If it's addition, we combine with multiplication. We check, is it the same base? If it's a minus, we combine with division. If we have any numbers out front of the logarithm, they become the new exponent. Okay, let's see how we do with problem number 50. Now when I look at the minus rule, that's going to make me automatically go to division, and that is the right law that we want to start out with. But notice before I use this law, I cannot have any constants in front of a logarithm. So in order to combine, I can't have any numbers out front. So we're going to have to do a little bit of work before we go to the law 2. And it's not so bad. We're going to say log base 2 of 5 to the 1/2. What we're going to end up doing is just taking this exponent, taking that number out front. We're going to take that number out front and make it the exponent. Now that I don't have any constants out front, law 2 applies. With that subtraction, I can combine with division. Notice it's when I combine one logarithm. If it's a minus, then I combine a and b with division. We don't write, which is a common mistake, log base 2 of 5/2 over log base 2 of 7 squared. That's not the same thing. So make sure that you don't do that with your problems. Okay, we've combined. We've made the expression smaller rather than larger. Okay, so as a final step, we might say log base 2 square root of 5 over 49, and that should be our final answer. Okay, so what we learned from the last example is we take care of exponents first. This 3 comes up to the top. This 2 comes up to the power. This 1/2 comes up to the power. Okay, once I don't have any constants in front of my logarithm, then I can start combining. Okay, so if it's a plus, that means this came from the numerator, 2 cubed and x squared. If it's a minus, that means that this came from the denominator. And so as a final answer, I'm going to say 8, which is 2 cubed, 8x squared, and then the half power is the same as the square root. Okay, we see minus, no numbers out front of our logarithm, so we're going to combine log base 5 of x squared minus 1 over x minus 1. We could stop here, but when we check our answers in the back of the book, we should notice that this is the difference of squares. And then what's going to happen with that x minus 1, they're going to cancel out. So there would be our simplified answer. Okay, that's the end of part 2.